View's multipass output allows us to create normal maps within View, and then we can save them out, edit them, and make them seamless in another application. So what we're going to do is create some geometry that we can render out using the multipass for the XYZ normal, and create some normal maps that we can use on rock objects and terrains and the like. So the easiest way to start this is really with procedural terrain, because it's going to give us a lot of geometry and we get a lot of control out of the altitude reduction. So we're just going to add a procedural terrain. I'm going to go ahead and turn off the zero edges after going into the terrain editor. And now you can create custom altitude reductions for this. You can also load in, double click and go into the terrain altitudes that come with View. You could load in any of these and render them out for normal maps. You could even use the default fractal to make an interesting looking normal. We're going to edit and create sort of a custom one. We're going to go into the altitude reduction, edit the function, and just so that you can get exactly the same output as I am getting, I'm just going to remove that vector seed. So just starting with the default, I'm going to switch over the simple fractal to a terrain fractal, and then change the wavelength to 4.5 on the X, Y, and Z. And now I want to use the 3D stratification filter for this. Make it a lot more interesting. What we're going to do is right-click and add in a filter node. Under recursive, we're going to select 3D stratification. We can now change our links around and connect this multiply by constant to the filtered vector. And we start to see that showing up. Now the intensity, or the processing strength, is set to 1 for all the way across. And because we're doing this before the multiply by constant, we do have these very large blocks, so a larger portion of the vector for the stratification. What we can do to reduce the intensity on each of the intensities, or each of the axes, is to just modify and bring down the processing strength. And gives us more of a blocky type look. We could change the layer spacing, say on the X to 3. And we could do 0.2 on the Y. We see more kind of strips showing up. Another thing we could do is add a little bit of a tilt, an angle, so that we don't have something that's completely square. So I could just add 15 degrees on the heading and the tilt for the X. Maybe do 8 and 5. So 5 for the heading and 8 for the tilt angle for the positioning. And that's going to give us more of a square strata type look. We could stick with that, or we could also extract the offset and apply a turbulence filter to that to distort the overall stratification. So I'm going to just reduce the amplitude just using a default, so we just have a little bit of distortion. You can see that showing up in the terrain editor. We'll go ahead and stick with that. Now what we need to do is set up a camera. What I'm going to do is switch over to the top camera and move it out. Go into the render options, render it to screen. We're going to set it to square. We have a square terrain. And now for too close to the terrain, depending on the height, we're going to have a lot of distortion. And for the most part, that will actually be okay, because we're going to be modifying this outside of the terrain editor, and a little bit of overlapping for the geometry really isn't going to be a big deal because of the way we're using the normal maps. But if you want something a little more uniform and still be able to generate a good normal, you can zoom out or move the terrain up quite a ways, and then adjust the focal length and zoom in. And I've just gone ahead and saved this scene as rendering normal maps underscore 01, so you can load this in from the project content. We can also go ahead and switch to the 4 viewports and just scale up the up and down axis a little bit. Give us a little more intensity. The stronger the intensity with this type of normal, the better, because we are using it on a very low-res object, where the normal map itself is not going to be related to the actual normal. Before we go ahead and render, there are a couple of things we need to take into consideration, and also a few modifications that need to be made. First thing is that the multipass outputs aren't typically anti-aliased. At least if you're running through the Xstream plugin, rendering through a host application. So it is a good idea to do this in the standalone application, where the multipass should be anti-aliased. Either way, it's still a good idea to render about twice as large as you're going to need the actual normal map, because we are focusing on geometry, and with the way the subdivisions are set up, if there's not quite enough subdivisions, it's possible to have a little bit of pixelation. Rendering larger will also increase the polygon quality of the procedural terrain. And because we're using a method where we have the camera very far out and we're zooming in, we may need to kind of force the terrain in order to increase the resolution. So I've gone ahead and rendered this at 480 by 480 just to show without any quality modifications. The polygon count is only 32,000. And this makes a fairly low resolution terrain, where we actually have the polygons bigger than individual pixels. And I do want to have about 1 polygon per pixel to get as much detail as possible. If we were to take a look, so we have about 32,000 is the total polygon right now. We can divide that by 2 because everything is triangulated, and then run a square root. And now that's about the equivalent of, because we do have some cropping on the outer part of the terrain, so that does reduce some of the polygons, but it's basically a 128 by 128 resolution terrain. So that's even lower than just a standard height field terrain. So for 480 by 480, we can multiply 480 times 480 and then multiply it by 2. We're going to need around 500,000 polygons in order to actually fill in the total amount of screen space that we have. Now, as we render this larger, it will increase the polygon count, but there is another way to increase this polygon count other than just rendering larger. So if we open up the procedural terrain, go to the procedural tab, what we can do is increase the quality boost and bring it up to 4 and render it out. And now we can see that the polygon count is 524,000, so that's about what we need for this scale. And we can see the difference primarily in the shadows and some of the diffuse areas, because procedural terrains do kind of run a fractal almost on the bump channel automatically in order to compensate for the lower resolution. But it's going to help with the normal map a lot. So I haven't turned on the multipass yet, and we do need to do that. I also am going to render this about higher resolution. Go ahead and use 1024 by 1024. So in the render options, we're also going to enable the multipass. Go to Edit. I'm not going to save it to disk. But under rendering component, or actually under the extra components, we're going to go to the XYZ normal and go ahead and turn that on. And that's really all we need. So now we can render this out again. So we have a little over 2 million polygons, which is exactly what we need to have about 1 polygon per pixel, or technically really 2 because it is triangulated. So every pixel is kind of 2 triangles, polygons. This is showing at a render display of 50%. Go ahead and make that a little larger. Take a look at the actual size. And now down here in the render output, we can change this to the multipass and select the XYZ normal. And here we have a normal map that we can save out and make a few modifications to in image editing program to make it seamless, and then apply that to our models to speed up render time and not have to use the bump channel, which can take a lot longer to render. To save this out as a 32-bit or 16-bit image, we are going to have to use a specific formats in order for that. I do want to use the PNG format for the final output, but that's going to be done in Photoshop because you can't really save out a 16-bit output from view in the PNG format. You do have to use another format first. So we can use a TIFF format or a PSD format for that. And we could also do a 32-bit image, but a 16-bit should be way more than enough. So just selecting the disk icon to save this channel, I'm going to call this Rock Terrain Strata, and I'm going to go ahead and select the PSD format, go to Options, and make sure that the Embed Alpha information is turned off. Select 16 bits, click OK, and then we can save that out. And this scene is saved out as rendering normal maps _01. So you can go ahead and load that in if you want to take a look at this specific scene in this current setup. You can also load it in and use it as a template if you want to create your own normal maps. Just modify the procedural terrain for any function that you want.